What's the vertex? What's the vertex? That's the point at the very bottom. H comma K. And the axis of symmetry? X equal to H. Remember, because it's a vertical line. And the focus? Have we seen the focus yet? No, I'm not going to give it to you yet. Okay. So far, how have you been able to graph parabolas? Well, you've graphed the vertex, right? And you put it somewhere here. This being H, this being K, this being HK. And then you usually find the y-intercept, right? Do you remember how to get the y-intercept? It comes from the original equation that you get, which looks something like this. It looks something like this. ax squared plus bx plus cy plus d equals 0. That's usually what you get, right? This one, 0 comma d, was the y-intercept. Y-intercept, okay? And since you have the axis of symmetry here, going through this, whatever distance you had here, you have to put on the other side, and then you drew your parabola. That's what you've been doing so far, correct? Now, you're only going to get this. So you could go back and turn it into this and find the y-intercept. Or you can use this, the 4p. Why? Because parabolas, when drawn, have from the focus, which I will explain in a second, 2p this way and 2p the other way, hence the 4p. That's why, depending on that number there, you will know if it's a wide parabola or if it's a narrow parabola. If it's a big number up here, it's really narrow. If it's a little number here, if it's a fraction, it's a wide parabola, okay? The focus happens to be, if this is h comma k, happens to be at p distance. And of course, mathematicians and physicists can never just do one thing in one direction. You have to do it in both, right? Because what you do on one side, you do on the other. So you find another point here, but instead of calling it a point, it's a line. And the line is P down, okay? So P up is the focus, P down is called the directrix, okay? The focus is one of those things that is extremely important because it's the place that is equidistant. If you were to take the parabola and spin it around, what do you think you get? What kind of a shape do you think you get? You take a parabola and you make it spin. Huh? Half an oval? No. You get a 3D shaped, that is a parabolic dish. Have you ever seen a parabolic antenna? That is if you take one parabola and you spin it around the vertex, you get that shape. The cool thing is that the focus, no matter how much it's spinning, is always going to be in the flat, in a specific point. And that point is going to be equidistant to any side of that dish. That is why when you see a parabolic dish, it always has like a thing here in the middle. Have you seen it?
No.
That thing is placed at the focus. And why is it placed at the focus? Because it's receiving all the signals and it has to portray them towards the dish again so that you get a signal in your television. If this isn't at the focus, what happens? The screen looks like there's no image. So the focus is one of those things that is really, really important, okay? Is it clear what the focus is? Now I'm gonna give you the formula for the focus. Focus, it's a point. Now, did I move P in the X direction or in the Y direction? In the Y direction. Therefore, who do I add P to? Y, but who's Y if I'm starting at H comma K, which is the vertex? Let me start over. What would this point be? Did it move in X or is it in the same place? You remember that this is X equal to H, right? Because all of these points are H, correct? That's why it's a vertical line. Yes or no?
Yes.
Okay. So this point here, does it have a different H?
No.
No. Does it have a different Y? Yes. How different? I know that this is K, so how much is this? K plus P. It's got the same H, but it's got a K plus P. Does everybody see why it's a K plus P? Because you went P up, right? And guess what the directrix is? If it's now a horizontal line, how much do you think it will be? If down here is minus P from K.
Minus PK.
K minus P.
K minus P. So the directrix is directrix is a line. Y equal to K minus P. Now, is it understood that once you find the focus, you move 2P this way, 2P that way, and you will find points so that you can draw your parabola in your graph. Now, this from here to there is like the general thing for drawing any parabola, anywhere, anytime, from any equation given to you that is parabolic. Is that part clear? Questions on how to graph this and where does it go, or we're good here? Because now we're going to do one, okay? The good thing is that, as far as I know, on this lesson, you won't have to find the focus and the directrix. But if I don't explain the focus and the directrix, the 4P doesn't make sense, okay? And I can't show you 2P and 2P. So that's why I showed you the whole thing, okay? Let me start. May I erase?
No, wait. The graph not
Huh?
the graph not in my.
Not the graph, but over there, yes.
Yes.
So can I erase your camera? Yes? Okay.
You have to draw a parabola. You have to draw the parabola.
Okay, so what are they going to give you? They're going to give you this. 3y minus x squared plus 2x plus 5 equals 0. What's the first thing you do? Besides, go completely silent.
Put in
Does this look anything like
y equals.
ah?
1 over
So
14.
3y equals x squared plus 2x minus 2x minus 5. Okay, now I have the y's on one side.
You divide everything by 3.
Divide everything by 3. So that's 1/3 of x squared minus 2/3 of x minus 5/3. Okay? Now what? What do I have to do? I have to get it like this somehow.
Oh, square. You find the square. Find the square.
So I have to complete the square, but I have to do something else before I can complete the square. I have to take out the 1 over 3, right? So 1 over 3. Remember that this is what it has to look like. Okay? That's what you have to get. Or it's almost there. 1/3 x squared minus 2x minus 5/3. Okay? So, completing the square, this would be plus 1. But if I add 1/3 times 1 is 1/3. If I add 1/3, I have to subtract 1/3. So I have 1/3 of x minus 1 squared minus conveniently 2. Right? Because it's 6/3, that's a 2. So I have everything I need. Let's see. First of all, vertex. What's my vertex?
One.
Add 1.5.
1,
No, 1.
1 minus 2. Very good.
One. Oh no, minus two.
Axis of symmetry. X equal to 1. You can't say just 1. It's got to be x equal to 1 because it's a line. Okay? Or it's an axis. P.
3.
Is it 3? I don't know. We know that 4p equals to 3, right? The whole thing equals to 3. So p equals 3/4. Okay. The focus. What's it gonna be?
1, 3, 3/4.
Minus 2 plus 3/4. Right? That would be how much? That would be minus 8/4 plus 3/4 is minus 5/4, right? Minus 5/4. Does everybody understand how I got the minus 5/4? How? This one here would be what did we say it was? Minus 2 plus 3/4. Because it's k plus p, remember?
Yeah.
Okay, that's how I got this. Okay, so now I have the focus. And now I can graph. Oh, how lovely. This is fractions. Okay. Vertex is at 1 comma minus 2. Minus 2, 1, so it's here. You know you have to do this more exact than me, right? Okay. What after the vertex? What do I do?
Y.
The axis of symmetry. Oh, you're good. So I have to draw my axis of symmetry going through that point. Okay, there it is. Now, I need the focus. Because it's from the focus that I need the two p's. So, the focus is going to be 1 minus 5/4. This is minus 2. This is a little bit under here. Right? Because it's not exactly at 1. It's a little under 1. Right? This is minus 1. And then from here, it's 2p on both sides. How much would 2p be? 2p would be 6/4, which is 3/2, which is 1.5. Right? So I have to move 1.5 this way and 1.5 on the other side. So 1.5 this way would be 1.5 here. 1.5 here. Right? And then I just connect the dots and draw my graph. Okay? Important, this here is 2p and this here is 2p. Is that clear? If this had been a 3, it would have been a very narrow parabola. Because, what would you do? Complicated, huh? I'll answer that when we get